Hello, in this video we will see how to evaluate a double integral over a rectangular region. So what do we mean by a rectangular region is that the limits for both the variables of integral is constant. So let's consider this example of a double integral. We know that the region is a rectangular region because if we look at the limits of this integrals, all are numbers, means constant. Okay, and I believe you remember how do we identify the limits here, like what are the limits for the variable x and what are the limits for the variable y. So to do that, what we need to do is check, like we map the elements, the variable like this. So the inner integral with the inner order of integral and the outer one with outers. Okay, so this gives you the limits of variable x is from 0 to 1. So x varies from 0 to 1, whereas for variable y it is from -1 to 1. And what will be the order of integration? It will be depending upon this. This is the idea, This is the inner integral. So first of all, we will solve this integral and then the second integral. So it is a step-by-step process. So let's begin with this inner integral. This is 0 to 1 x plus y power 2 dx. Now, if you remember the basics of double integral, here because of this dx, we know that we are integrating with respect to variable x, and which variable is a constant? All the other variables will be kept as constant. So here we have only y as the other variable. In triple integral you will have a third variable as well. So in that case there will be two variables which will be kept constant. We will discuss about that later. Okay, so here we have in the first term x with which we are integrating, but in the second term if you see you don't have any x term. So what will be the integral of this? We have x, so we are integrating with respect to x, so the integral become x power 2 over 2 because x is same as x power n. So we are using this rule, x power n plus 1 over n plus 1 plus c, where n is not equal to -1. So by using this rule we get this. Now y square is a constant, so it is y square times, as there is no x we multiply with x. It is similar to like integrating 2 dx, 2 being constant, so the integral is 2x plus c. Okay, so now after that substitute the limit. X varies from 0 to 1. So whenever we substitute the limit, we always replace first x by 1 and then z by 0. So we have to change x, the value of x in both the places. So let's do it. It is 1 square over 2 plus y square times 1 minus, replace x by 0, so it becomes 0 square by 2 y square times 0. So what we did basically, we replaced x by 1 first and then by 0. Okay, so we can say that this is the limit at x is equal to 1 and this is at x is equal to 0. Now let's simplify it. So we can easily simplify. You left here with 1 by 2 and here with y power 2, and this entire term becomes 0. So what we can see, once we integrated with x and substituted the limits, we don't see any x term. So this is a way to check that you are doing it correct. So once you integrated with respect to one variable and substituted the limits, means the variable should not appear again. So in case you are seeing a variable here again, it means you have made a mistake. So now this was the value of this inner integral. Now we will use this value to evaluate the final integral, which is with respect to the variable dy. So we have integral -1 to 1 and the value of this bracket is this term 1 by 2 plus y square and integrate it with respect to y. So this becomes a normal question of single integral. You can see that you have only the variable y. You don't see variable, any other variable at any other place. Okay. So it's a question of normal integral integrated. So what we will get? 1 by 2. Again there is no y term, and you're integrating with respect to y. So this gives you the answer 1 by 2 times y plus y square. So it will be y power 3 over 3. We have used the same rule that we used for the previous integral. Now here the limits for y equal to minus 1 to 1. Again we substitute the higher limit first and then the lower limit. So it is 1 by 2 times 1 power 3 over 3 minus 1 by 2 times minus 1 and minus 1 to the power 3 over 3, and then we simplify it. So this term, first term gives you 1 by 2, this is 1 by 3, with minus it become plus 1 by 2, and this minus 1 3 times gives you negative become positive, so 1 over 3. So when you add all these, you will get 1 plus 2 over 3, so it will be 5 over 3, which is a number. So this is the final value of the integral. So we have minus 1 to 1, integral 0 to 1, x plus y square dx dy equal to 5 over 3.